I'm Thompson. I was an undergraduate at Oklahoma State University where I got my degree in physics, and then I was a graduate student at the University of California at Berkeley in chemistry where I did exact quantum reactive scattering, gas phase reactions. Then I was a postdoc at the University of Colorado at Boulder where I worked on things like push-pull polyenes and proton transfer and phenomena in liquids. We do theoretical chemical dynamics, so we're essentially interested in the timescales and mechanisms by which chemical processes happen. We look at liquids primarily in sort of more complex environments, so we're interested in things like the solvated electron, liquids inside mesoporous materials where the liquid is confined on a few nanometer length scale, or even assemblies like supramolecular assemblies, complex organic structures in liquids. What we try to do is to develop methods and then apply them to those kinds of systems to make predictions about experiments that haven't been done or explain experiments that have been done. And we spend a lot of time thinking about driving forces. What are the enthalpy and entropic driving forces? Develop methods for calculating activation energies from simulations at a single temperature so we can find out what the underlying barriers are for the processes that are of interest. Every student in my group has their own project that they are responsible for and drive forward, and everything that happens really happens because of and by the students. Almost every project that we have, not every project, but almost every project has a collaboration, oftentimes with other experimentalists. So we collaborate with an experimentalist at the Notre Dame Radiation Lab on the hydrated electron. We collaborate with geochemists at San Diego National Lab. We've collaborated with other people at Stanford and Penn, and we have a long-time collaboration with another theorist who's in Paris. For every student, we sit down and talk about what their long-range plans are, and then we develop the classes that they're going to take and the experiences they're going to have, the conferences that they go to, the teaching that they might do to match that goal that they have. And then, in the students and postdocs who come out of my group are in industry and national labs and academia, but everybody has sort of an individualized path. As theoretical and computational chemists, we primarily use the computational cluster that's on campus that is a community cluster that's used by the entire university community.